When installing explosion-proof conduit near cathodically protected gas piping, it's crucial to electrically isolate the two systems. Cathodic protection is designed to prevent corrosion in buried or submerged metallic structures, and introducing a grounding path through the conduit can compromise this protection. Here are several methods to achieve this isolation. Firstly, consider installing an insulating joint between the conduit and the cathodically protected pipe. This joint acts as a physical and electrical barrier, preventing the flow of current between the two systems. It is critical that the insulating joint is rated for use in hazardous locations and meets the requirements of UL 467 for explosion-proof enclosures. Secondly, an isolating flange can be installed between the conduit and the pipe. An isolating flange is similar in function to an insulating joint but uses a flange connection. Use a gasket or other non-conductive material within the flange assembly to ensure electrical isolation. Like the insulating joint, the isolating flange must be explosion-proof and meet the requirements of UL 508 for explosion-proof devices. Thirdly, using non-metallic conduit for the entire run from the solenoid to the power source is an option. Non-metallic conduit, such as PVC or fiberglass, does not conduct electricity, thus eliminating the need for a ground connection and preventing any electrical interaction with the cathodically protected piping. This method simplifies the installation by removing the potential for electrical shorts or interference. Fourthly, install couplings with isolation inserts between the conduit and the pipe. These inserts provide electrical isolation while maintaining mechanical continuity. The inserts are typically made of a non-conductive material and are designed to fit within standard conduit couplings. It is imperative that the couplings and inserts meet the requirements of UL 467 for explosion-proof enclosures. When selecting an isolation method, consider the specific gas heater and solenoid requirements. The chosen method should be compatible with the voltage, amperage, and environmental conditions of the installation. Ensure that the selected components are rated for use in hazardous locations and can withstand the potential for explosive atmospheres. Always follow all applicable electrical codes and standards, including National Electrical Code Article 501 and NFPA 70. These codes provide detailed guidelines for electrical installations in hazardous locations, including requirements for grounding, bonding, and explosion-proof equipment. Article 501 covers specific requirements for Class I, Division 1 and Division 2 locations, which are areas where flammable gases or vapors are present or may be present in ignitable concentrations. NFPA 70 provides a comprehensive set of standards for electrical safety, including requirements for wiring methods, equipment, and installations. It's wise to seek guidance from qualified electrical and corrosion protection professionals to ensure proper installation and maintenance. These professionals can assess the specific site conditions, evaluate the effectiveness of the cathodic protection system, and recommend the most appropriate isolation method. They can also provide guidance on grounding and bonding requirements to ensure a safe and reliable electrical system. Remember, proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. Bonding connects metallic parts of the electrical system together, creating a low impedance path for fault current and minimizing voltage differences. In hazardous locations, explosion-proof equipment is required to contain any internal explosions and prevent them from igniting the surrounding atmosphere. Explosion-proof enclosures are designed to withstand the pressure of an internal explosion and prevent the escape of flames or hot gases. Conduit seals are used to prevent the propagation of flames or gases through the conduit system. When installing explosion-proof conduit, it is important to use the correct type of fittings and seals. The fittings must be rated for use in hazardous locations and must be properly installed to maintain the integrity of the explosion-proof system. Conduit seals must be installed according to the manufacturer's instructions to prevent the passage of flames or gases. Regular inspections and maintenance are essential to ensure the continued effectiveness of the isolation method and the integrity of the explosion-proof system. Inspect the insulating joints, isolating flanges, and couplings for signs of damage or corrosion. Check the non-metallic conduit for cracks or deterioration. Verify that the grounding and bonding connections are secure and free of corrosion. Testing is also important to ensure the electrical isolation is effective. Use a multimeter to measure the resistance between the conduit and the cathodically protected piping. A high resistance reading indicates good isolation, while a low resistance reading indicates a potential problem. If any issues are identified, take corrective action immediately. Repair or replace any damaged components and retest the system to ensure proper isolation. Maintaining detailed records of the installation, inspections, and maintenance activities is essential. These records can be used to track the performance of the isolation method and identify any potential problems. The record should include the date of installation, the type of isolation method used, the results of inspections and tests, and any corrective actions taken. When working with electrical systems in hazardous locations, always follow safe work practices. De-energize the circuit before performing any work. Use appropriate personal protective equipment such as gloves and safety glasses. Be aware of the potential hazards in the area such as flammable gases or vapors. By following these guidelines, you can safely and effectively isolate explosion-proof conduit from cathodically protected piping, ensuring the safety of personnel and equipment. The most appropriate method will depend on your system setup, local requirements and safety regulations.